In this video, we're going to review linear inequalities, something you should have already learned before this class, but perhaps you don't remember how to do it. Then we'll be talking about absolute value equations, and then we'll combine the two. Absolute value equations in linear equalities. On the screen, you should be able to see a handout that you will find in the 055 folder on D2L. It's called Linear Inequalities. If you want to take a moment to go and open up that handout, you can follow along, or you can simply watch the screen and open it later. If you see up here, this talks about the addition property of inequalities. The addition property of inequalities basically says if you add or subtract the same quantity to both sides of an inequality, you will not change the solutions to it. Let's look at an example. You can see here that we have 4x minus 8, which is less than or equal to 5x plus 4. I need to get my two x terms on the same side. I have a choice to move the 4x or to move the 5x. As before, if you move the smaller of the two variable terms, you will not have to deal with the negative. So I choose to move the 4x by subtracting 4x from both sides of the equation. When I do this, I will end up with negative 8, the constant by itself on the left, less than or equal to x plus 4. Now I need to isolate the x variable by moving the plus 4 to the left side to join the negative 8. So I subtract 4 from both sides of the inequality. Like in an equation, an inequality balances here on the inequality symbol. So I will subtract 4 from both sides of the inequality. According to the addition property, adding and subtracting does nothing to change the solutions. This gives me the equation negative 12 less than or equal to the variable x. This is not the way it is typically written in high school classrooms. In high school classrooms, it is typically written with the variable on the left. But in a college classroom, it does not matter which side the variable is on, as long as the variable is on the same side of the symbol. If you look at the symbol in the left inequality, the wide end of the symbol here is closest to the variable. In this rewriting of that same inequality, notice that the wide end of the symbol is still closest to the variable x, and the narrow or pointed end of the symbol is close to the negative 12, just as it is in the original version of it. The open end is pointed at x in both cases. This is the same as saying negative 12 is smaller than or equal to x, or x is larger than or equal to negative 12. Now, how would you produce this on a graph? A graph for this, since it only involves one variable, would be a single number line. And you can see that right here. This single number line, we need to mark off the important points. 0 is always an important point. 0 should always appear on all of your graphs. If it's a two-dimensional graph of x and y, you should show the origin. When it's a one-dimensional graph, like this one, we just need to mark off where 0 is. Since the only other value in these inequalities is negative 12, I mark it off as well. To graph it, I need to choose either a solid ball or an empty ball. I look at the symbol, which is either less than or equal to, reading from left to right, small n first is less than, or greater than or equal to, reading from left to right, large n first is greater than. But both have the half of an equal sign underneath, which represents could be the same as. That means solid ball. So you'll see here I have a dark black filled circle. Now, which direction do I go, to the left or to the right? Since the variable is on the open end or the wide end of both symbols, that means go to the right. So from the closed ball, I go to the right. Now, how would we write this in notation? Let me type it in for you now. To represent this in the notation, I need to show that it's a closed dark ball, that it's completely filled in. I use a square bracket to do that. I need to mirror the relationship of which side the negative 12 and the ball are on and which way the arrow is. Notice that the ball, the negative 12, is on the left, so it must appear on the left in the notation. Then I have a comma, and then I would put next to it infinity. Now I can't insert the infinity symbol on this, so I'm simply going to write out the word infinity. I-N-F-I-N-I-T-Y. Oops, maybe I have too many infinities in there. So if I take out those two, how will I end this? Should I use another closed square bracket? And the answer is no. Infinity is a direction, like go south, but it's not a number like 12 or negative 12. With infinity and negative infinity, we always use a round parentheses. So one way to write this is negative 12, comma, infinity, round parentheses. We can also write this in another way, what is called set notation, where I use a curly bracket on the left to indicate this is a set. Then I would write the set of all x values. So I would type in the x, and it would be the set of all x such that, oops, too many x's. So I would put in a long vertical bar, and that would represent such that. So it reads the set of all x such that, and now I need to give the rule. Now, unfortunately, when I'm typing, I won't be able to put in the inequality, so I'll have to write greater than or equal to as two separate symbols. And then I just give the rule. X is greater than or equal to negative 12, or I could have written negative 12 less than or equal to x. And then I close the set notation with another curled bracket. That's how this one would be represented. Let's look at the next property of linear inequalities. This is called the multiplication property of inequalities. We now need to multiply or divide both sides of an inequality by a number. However, unfortunately, this rule has two parts. If the number is a positive number, then when I multiply or divide both sides, it does not change the solution of the inequality. In other words, the symbol doesn't change and I don't change the solution. Let's look at the example here on the left. 2 times the quantity 3x minus 1 greater than 4x minus 6. The first thing I need to do is to distribute the 2 over each of the terms in the parentheses. So 2 times 3x gives me 6x, and then 2 times negative 1 gives me negative 2. On the right-hand side, nothing has changed. At this point, I need to evaluate and look at this equation here in the second line and decide which x term to move. Because 4x is smaller than 6x, I choose to move 4x to the left side by subtracting 4x from each side. That means the constants will end up on the right-hand side of the inequality, so I'll add the 2 to move the negative 2 to the right. When I combine like terms, I get the inequality you see here in the fourth line. 2x is greater than negative 4. To solve, I need to divide both sides. Although this number on the right is negative, the number I'm actually dividing by, you'll see here, is actually a positive 2. Because I'm dividing both sides by a positive number, I do not need to reverse the inequality. I simply divide by the positive, and even though the result here on the right is negative, the number I divided by is positive, so the result is the same. I have got the solution, x is greater than negative 2. This would be the same as saying negative 2 is smaller than x, reading backwards. So again, we could turn the whole thing around, but typically if we have the variable on the left, we leave it alone. Now what would this look like on the graph of the number line? Again, you produce the number line with an arrow at each end. You must mark off where 0 is, which you can see here. And then you need to consider whether you need an open ball or a closed ball. In the previous example, it was a dark black filled-in ball. But this time, I do not have that or equal to half of the equals under the inequality symbol. So the circle I draw right here, this must be empty. Now, which way should I go? Again, it's not whether I have greater than or less than, it's which side of the symbol is the variable on. The wide end of the symbol is open to the x, therefore I go to the wide end or the larger end of the number line, which is to the right. Now what would this look like if I typed in the values? Let's do the notation again. If I type in the notation, I need to indicate that this circle is actually open and not solid closed. I do that with a round parentheses. Again, I have to mirror the order. -2 is on the left, the arrow's to the right. So -2 must appear on the left, comma, and again I must type in the word infinity, and then I will use a round parentheses next to the infinity. That's called interval notation. For set notation, I start with the curly bracket on the left, then I will talk about the set of all x such that, which you can use the long vertical bar or you could use a colon, the set of all x such that, and then I would give the rule. I could say x is greater than -2. And then I would close the set with another curly bracket. What would happen if I were to multiply or divide both sides of an inequality by a negative number? This is a different situation. When you multiply or divide both sides of an inequality by a negative number, it reverses the sense of the inequality. That is, it reverses the actual inequality symbol itself. It turns it around the other way. Let's look at this example and see how that works. We start with 1 less than 3 minus 4 multiplied by the quantity 3a minus 1. In the next line, I have distributed the -4. I am multiplying by a -4, but only on the right side of the inequality here using the distributive property. That's not applied to both sides, so it does not reverse the symbol. Instead, I just distribute and I get -12a, and then I get -4 times -1, which gives me +4. At this point, I should combine the like terms 3 and 4 since they're both constants and both on the right side. When I add them together, I get 7. Now I have 1 less than 7 minus 12a. I can see I have two constants in the equation and only one variable term, 12a. So I decide to move the 7 by subtracting it from both sides of the inequality. This is that addition property of inequality, which does not change the direction of the inequality. So when I subtract, even though I get a -6, the symbol stays less than. And I get -6 less than -12a. The next step is the problem step. When I divide to isolate a, I have to divide by a negative number on both sides. It's not that the numerators are negative. The numerator's sign does not matter at all. It's only the sign of what you're dividing or multiplying by, in our case, a -12. That's going to take this less than and turn it around so that it becomes greater than. When I complete the equation, I get 1/2 is greater than a. We can also turn this around as long as we maintain that the a is next to the narrow pointy end of the symbol, as you see here, and the 1/2 is on the wide end of the symbol. When we come out here, notice that a started at the beginning on the wide end of the symbol, but the division by the negative caused it to end up on the narrow end, so it changed. When we graph this, we will again have the number line with 2 arrows on each end. Again, you must mark 0, and you can mark 1/2. It is not necessary to mark off 1, 2, 3, or 4. All you need is 0 and the other number. Because we do not have the or equal to, we must have an empty circle here. Now, do we go left or do we go right? When I look at both of these ways of writing the same inequality, I see that the variable is on the small end. That means go to the small side of the number line, which is to the left. Now, what would this look like in our notation? Let's take a look. When we do the notation, which you will see here above the picture, I would start at the far left side. This time, though, I'm starting on the arrow end, which is negative infinity. So I must use around parentheses a negative and infinity. Then I would have a comma, and then I would write the value that is on the right end of the number line, which in our case is 1/2. That's where it stops. So I'd have 1 divided by 2. Should I have a square bracket or a round one? An empty circle is a round bracket. A solid circle is a square bracket. That's the end of this part of this video discussing the linear inequalities. Now we want to take a look at absolute value problems before we put the two together. When we think of absolute value, we like to think of it as the distance between a number and 0 on the number line. That is, this is the number of unit steps you must take to get from a number to 0 on the number line. Let's look down a bit. If you look here, you can see that I have a number line drawn. Here's 0, which represents the origin on the number line, and here's a number, 4. How far away is the 4 from the 0? I would take 1, 2, 3, 4 steps to get from 0 to 4, so the absolute value of 4 is 4. When I look at this number, which is -4, it is also 1, 2, 3, 4 steps away from 0 on the number line. Therefore, its absolute value is also 4. Distance is never negative. Therefore, absolute value is never negative. It can be 0 or it must be a positive number. How do we express this mathematically? Let's look. Expressed mathematically, if A absolute value is equal to B, then either A is B or A is the opposite of B. That is, they're either really the same number, 4 is 4, or they're the same distance but on opposite sides of 0, 4 and -4, because a double negative on 4 is still 4. That means the absolute value of 4 is 4 or -4. Let's take a look at an example below. In this example, we have the absolute value of the quantity 4/3 multiplied by y minus 2, close the quantity, plus 3 equals 10. I cannot resolve this problem until I have isolated the absolute value. That means any number added to it has to be moved to the other side of the equation. It also means if there happened to be a number multiplied or divided but outside the absolute value, it would also have to be moved to the other side before I can evaluate the absolute value. Once I have isolated the absolute value and its line is the first on the left and the last on the left before the equals, then I can split it into two equations connected with the word or. That means either 4/3 y minus 2 really is 7, it's on the same side of 0 on the number line, or it's on the opposite side, meaning 4/3 y minus 2 was sitting at -7. We solve each of these the same we would do any linear equation. To move the -2, I add 2 to both sides in both equations. And the one on the left, the 2 plus 7 would give me 9. Then to move the 4/3 off the y, I need to multiply by the reciprocal, which is 3/4. When I multiply 4/3 by its reciprocal 3/4, the 3's cancel, the 4's cancel, and I get 1. On the right-hand side, I can think of the 9 as 9 divided by 1, or I can simply multiply straight across and get 27 divided by 4. That gives me the value of y if it really was on the right side of 0. What if it were on the left? If it were on the left, when I add 2, I would get 2 plus -7, which is -5. Again, I have to multiply by 3/4 to remove the 4/3 factor on y. When I multiply that by -5, I get -15/4. That means there are two possible places where y could be so that this equation is satisfied. Y could be at 27/4 or y could be at -15/4. And in both cases, this 4/3 y minus 2 would be a distance of 7 steps from 0 on the number line. Let's think about some special cases. The first special case is when you get an absolute value equal to a negative number. If you have an absolute value equal to a negative number, there is no solution. Absolute values represent a distance, a number of steps away from 0 on the number line, so it is not possible for them to be a negative number of steps away. I've never been -10 feet from anything. So in this case, we would say there's no solution. Sometimes you cannot tell because it could be that it had a number here on this side that when you moved it made this a negative. That's why it's important to isolate the absolute value first. Always look to be sure that your absolute value isolated is equal to a positive number or 0. If the isolated absolute value equals a negative, there is no solution. What if you have two absolute values? Then they're either both on the same number line, so they're truly equal, or they're opposites. We will not be studying this case this semester, but you will be looking at it in college algebra. Let's move to the next case. I'd like to take a look at these two examples. I'm going to work number 2 and then number 3. So if we're looking at these examples, number 2 says the absolute value of 3x minus 1 in absolute value plus 2 equals 5. Now, if I have that equation, what do I need to do first? Isolate the absolute value. So I'm going to move the 2 by subtracting 2 from both sides of the equation. That leaves me absolute value of 3x minus 1 equal to 3. Because the absolute value is equal to a positive, this is possible. This means either it is 3 steps away on the right or it is 3 steps away on the left. So I either have that 3x minus 1 equals 3, or I have that 3x minus 1 equals -3. In both cases, it's 3 steps from 0 on the number line, 1 to the right, 1 to the left. I solve these separately. I'm going to move the 1 by adding. That gives me 3x equals 4, and then I divide both sides by 3. That tells me, oops, that should be an equals. That tells me that x could be 4/3. That's one possible solution. What about this one? Add the 1 to move it to the other side. That gives me 3x equals -2. To solve for x, I isolate it by dividing by 3, and that gives me -2/3. That's the other possible solution on problem number 2. There are 2 solutions. I could show this solution set by writing these 2 answers in curled brackets with a comma in between. It doesn't matter what order they're in because this is a set, but I would not put them in round parentheses or square parentheses because it is not an interval. These are 2 points. Only -2/3 and only 4/3 will solve that problem. Let's look at number 3. Number 3 is a special case. When we look at number 3, we see that we have the absolute value of 4x minus 7 plus 6 equals 4. When I first look at this problem, everything looks fine. I don't see anything that should cause a problem. However, when I move the 6, I have to subtract it from both sides. And this would give me the absolute value of 4x minus 7 equal to -2. When I have 4x minus 7 equal to negative 2, I have a problem. This means that the absolute value is equal to a negative. A positive or zero distance equals a negative number. This cannot happen. I can stop right here and I can write no solution. There's no answer to this problem. Let's now take a look at compound and continued inequalities.